Hello, students, and a very warm welcome to Notebook. Congratulations to all of you for getting promoted to 10th class. Today, we will start with the first chapter of our mathematics, which is real number. But before that, let us quickly recall what we have studied in previous classes regarding numbers. So, let's start. Students, do you know what natural numbers are?
Natural numbers are the numbers 1, 2, 3, 4, 5, 6, and so on.
Correct. Very good. Students, is there any number which, when added to any natural number, gives the same natural number?
0 is such number. For example, when we add 0 to 5, we get 5 as the answer.
Correct. Excellent. So, students, tell me, what are these numbers called?
These numbers are called whole numbers.
Correct. These numbers are whole numbers. So, students, now tell me, what is the difference between natural numbers and whole numbers?
Natural numbers start with 1, whereas whole numbers starts with 0.
Very good, students. Now tell me, what are these numbers called?
These numbers are called integers.
Yes, students, these numbers are called integers. Well, students, now that we have revised what natural numbers, whole numbers, and integers are, let us also recall what rational numbers and irrational numbers are. So, students, we know that rational numbers are the numbers which can be expressed in the form of p by q. P and q are integers and q is not equal to 0. For example, 2 by 3, minus 5 by 7, 8. Since we can write 8 as 8 by 1. So all the integers are also rational numbers as they can be expressed in the p by q form. Also, since square root of 4 is 2, therefore it is also a rational number. This tells us that it is not necessary the square root of a number cannot be a rational number. I hope now it is clear to you which numbers are rational numbers and which are not. But wait, what do we call those numbers which are not rational numbers? Yes, you guessed it right. Those numbers are called irrational numbers. Let us have a look at the formal definition of irrational numbers. Students, we know that any number which cannot be expressed as the quotient of two integers is called an irrational number. For example, square root of 2, square root of 5, etc. So, students, now that we have revised rational and irrational numbers, we can easily answer what real numbers are. So, all rational and irrational numbers together form the real numbers. Let us summarize what we have discussed with the help of the following diagrams. So, the natural numbers are the numbers 1, 2, 3, 4, 5, 6, and so on. Whole numbers are the numbers 0, 1, 2, 3, 4, and so on. Integers are the number comprising of all the negative natural numbers and the whole numbers. And rational numbers are the numbers which can be expressed in the form of p by q, where q is not equal to 0. Also, real numbers comprises of all the rational and irrational numbers. So, students, now let us move on to our first concept of this chapter, which is Euclid's division lemma. Let us try and understand it through the following illustration. Avinash and his friends were standing by the road when the trader selling eggs came and stood by the other side of the road. Looking at his eggs, Avinash said to his friends,
Let us count the eggs, but I will count them in pairs. Rahul, you count them in threes. Priya, you count them in fours. Devansh, you count them in fives. Anamika, you count them in sixes. And Abhay, you count them in sevens. So let's start. So after counting the eggs, this is what they said to each other.
If counted in pairs, 1 will remain.
If counted in threes, 2 will remain.
If counted in fours, 3 will remain.
If counted in fives, 4 will remain.
If counted in sixes, 5 will remain.
If counted in sevens, nothing will remain. How many eggs can your basket accommodate? My basket cannot accommodate more than 150 eggs.
So, students, the question arises, how many eggs were there? Can you tell? Let's find out. Let us assume that the number of eggs are A. Since the basket cannot accommodate more than 150 eggs, so A is less than or equal to 150. Now, according to counting done by children, if counted in sevens, nothing will remain, which means A is equal to 7p plus 0 for some natural number p. If counted in sixes, 5 will remain, which means a is equal to 6q plus 5 for some natural number q. If counted in fives, 4 will remain, which means a is equal to 5w plus 4 for some natural number w. If counted in fours, 3 will remain, which means a is equal to 4s plus 3 for some natural number s. If counted in threes, 2 will remain, which means a is equal to 3t plus 2 for some natural number t. If counted in pairs, 1 will remain, which means a is equal to 2u plus 1 for some natural number u. We notice in each case we have a and a positive integer b, which takes values 7, 6, 5, 4, 3, 2, which divides a and leaves the remainder r, in this case 0, 5, 4, 3, 2, and 1. Also, r is less than b in each case. All these equations that we have written are using Euclid's division lemma. So students, all the equations which we have written are an example of Euclid's division lemma. Also students, what is the answer of our puzzle? How many eggs did the trader have? For this, we use trial and error. As we have a is equal to 7p, a is equal to 6q plus 1, a is equal to 5w plus 4, a is equal to 4s plus 3, a is equal to 3t plus 2, and a is equal to 2u plus 1. By using LCM, we get a is equal to 119. So the trader had 119 eggs. Students, now that we have solved our puzzle, let us have a look at the formal statement of Euclid's division lemma. Students, Euclid's division lemma states that given two positive integers a and b, there exist unique integers q and r satisfying a is equal to bq plus r, where r is greater than equal to 0 and less than b. Students, now the question arises, if you are given two positive integers a and b, how will you find q and r which satisfies the Euclid's division lemma? Don't worry, I'll help you. Students, whenever you are given two positive integers a and b such that a is greater than b, then the easiest way of finding q and r is that we divide a by b. Now the value of your quotient is your q and the value of the remainder is your r. Let's understand this by the following example. Suppose we are given two positive integers 29 and 3. On dividing 29 by 3, we get quotient as 9 and remainder as 2. So the value of q is 9 and r is 2. Now substituting this value in a is equal to bq plus r, we get 29 is equal to 3 into 9 plus 2, which is true. So students, I hope Euclid's division lemma is clear to you. If you have any doubt, please go through the session again. In our next session, we will see the algorithm involved while applying the Euclid's division lemma to given integers. Till then, stay healthy and keep learning. Goodbye.